Yep.
Okay, my name is Jennifer, and I'm one of the judges today.
Hi,
I'm
Jennifer.
Dan. Hi. Good morning. I'm James. Hello.
Good morning.
And you will have 5 minutes to present, and then after that 5 minutes, we have 10 minutes to talk to you guys. At the 4-minute mark, I'm gonna put up this finger. Can you see it? Saying
Yep.
that you have 1 minute left, okay? Let's go ahead and get started. 3, 2, 1, go.
Good morning. We're Team 11908, the Gardner Edgerton Advanced Robotics, also known as GEAR. My name is Gavin. I'm the head builder.
My name is Jackson. I help with building and programming.
My name's Sydney. I float around and help out where needed.
I'm Bradley. I'm the lead programmer, and I also help out with documentation.
Clicker not working. Alrighty. So today we're going to talk to you about our 2020 through our 2021 season. I'm going to start out with the different challenges that we have faced, which have been many, and I'm sure many teams have faced challenges. I'm going to start off with challenges related to like the pandemic and our school not having classes until just recently, and our struggled to get authorization to meet in person, which means we had to meet via Zoom, which it worked, but we weren't able to quite accomplish all the things we needed to. And what came along with that was we lost one of our main sources of funding, which was our school concession stand. So we had to work a little extra harder to get the funding we needed this year.
Some additional challenges we faced was every now and then a deadline would show up faster than anticipated, so we'd have to schedule extra practices or work sessions in order to meet it. We also didn't always have the tools necessary to complete a task, so we'd have to improvise. Once hybrid started up, not all of our team members would meet on the same day, so to troubleshoot this, we would have to show up early, up to 30 minutes early before, so we could get into robotics on time. Also, our previous lead programmer graduated and Android Studio did not work out, so we ended up having to ditch the new software. Some more challenges we faced was the old design of the robot was too low to the ground, so the rings would get caught underneath. So to fix this, we raised the robot up, so now they just go right under.
So some highlights we had this year was attaching a drill to our launching mechanism and seeing the rings fire. We also liked the Cobras fundraiser that we did, and also we liked when we met at one of our customers' house to get more work done.
Our robot design has changed a lot over this season. We started off with a more of a closed box design that limited our ring firing capabilities. We ended up taking off the top structure so that we could open the robot up more and be able to fire rings better.
And this is a closer up picture of this guy. It's the arm or claw, like I like to call it. And we use this to grab and move wobble goals. And it's basically just some 3D printed claw pieces with a servo on the end of an arm. And it works pretty well for what we need to do.
Our ring collector is 5 wheels that spin, sucking the rings up into our launching mechanism that are then moved by a chain up into the flywheel.
And this is the launcher. You can see the pictures on the left, the chain that he was referring to that feeds the wheel with rings. Then on the right side we have a wheel which it spins really fast, and we like to call it the spinny wheel of death because of that.
This is the side view of the robot. On the left, you can see the ring collector leading into the launcher, covered by a piece of cardboard that helps the rings from popping out, and then up to the wheel that shoots the rings out.
Okay, in this picture you can see where we put the battery on the where we found where to put the battery on the bottom. Also, you can see the
This is the top view. You can see the cardboard on the launching mechanism, and also the arm.
And this is the back view. It just gives you a bit more of a look at how the ring collector interfaces with the launching mechanism.
Okay, so in conclusion, we faced many challenges this year, and we've enjoyed persevering through them. We've made a whole lot of this year. We made this is the first year we had our own practice field, and we found a new assistant coach because our last one had to go into service. we learned that through perseverance and determination we could do a surprising amount.
Despite all the challenges we faced, we still managed to make great memories and enjoy the season. What questions do you have for us?
Well, thank you guys, that was great. Thank you again so much for being here, and yeah, you certainly have accomplished a lot this year. Real quick, you, at that last conclusion about getting a new coach, how did you go about getting that new coach?
One of our team members is parents, on volunteer.
Actually, my dad volunteered to help out because our other assistant coach had to go into service this past year.
When you called every business in town, so to speak, what kind of sales pitch did you use?
Something like we're from Garden Edgerton. Do you have a open spot for us to fundraise? Something like that.
So
I was the one who did most of the fundraising isn't here today. She had to take the ACT today.
That's understandable. Priorities, you gotta stick with those priorities. So on your design that you showed, can you show us directly your robot right there and not,
Yeah.
take your shared screen off and see if we can get the camera to your robot? I really, your low, excuse me, your low,
Clearance?
thank you. Thank you, Dan. Your low clearance for that robot, how is, and it looks like your angle's fixed. How are you, were you shooting for the high goal, or what was your objective?
We were planning to shoot for the high goal, but because of the way that it works, we had to end up shooting for the mid goal.
Yeah, and then like we were just kind of experimenting with how the angle affected things, and we kind of noticed that like with this right here, if we had a fresh battery on, it could typically make the high goal, but if our battery was a bit more depleted, it would typically make the mid goal. And we found this angle was just about good because it would kind of strike that balance between high and mid and not just going into the low goal or shooting too high.
When,
Thank you.
Good. It looks like the angle is a little bit less than 45 degrees. So, why that angle? Why did you try to do angles higher than 45 degrees or about 45 degrees?
We played around with lots of different angles. It's kind of a mixture of, we had a bit of trouble getting the rings into the launching mechanism from the floor. And then also this angle just worked best for shooting it into the mid goal and then sometimes to the high one.
And then
I did,
on your chassis, you chose, like I'm looking at Omni wheels, with your chassis, you look at the angle. Where was the thought process in terms of determining your chassis and wheel design?
We decided to go with this wheel design because these are the wheels that we had. We didn't have the necessary funding to get the fancy Omni wheels. So this lets us do the 0-point turn too, and our chassis is a little bit under 18 inches in each direction, so it gives us room to have a little bit of stuff on the outside if we need to, but also gives us enough space on the inside for anything that we need to house in there.
And your wobble goal attachment, was it fabricated? You said you 3D printed that. Was that your own design, or did you get that from a shared source, or?
Yeah, so this guy right here, I think Gavin here designed it on Tinkercad, and we 3D printed a couple different versions of it, but it was mostly our design.
Dan, did you print something?
yeah, Sydney, you mentioned deadlines that you were sometimes struggling against. Could you or one of your teammates explain how these deadlines were determined?
We were trying to get a few practice matches in, but the design changed multiple times, and so we would work over the weekends at a co-sponsor's house, as we mentioned, in order to meet them. And we did get it by competition, so it did work out.
In a little bit more detail, the deadlines were more of a social thing, you know, like if we, to feel like we have done progress and make sure that we are actually going to be done by that time, we mentally fabricated some deadlines that we would need to pass.
Right, that's what I'm getting at. So what's your process for team design and organization to figure out what tasks need to get done by a certain date?
It's mainly, we're trying to shoot for some of the competitions, like the practice ones. So we set up a list of all the things that we needed to have done, and then we'd be like, okay, these 2 people can work on the launching mechanism, and these 2 people can work on programming. And then our next practice competition is a week from now, so we want this done by Monday so that we can have some time to practice. It just kind of was determined by when our competitions were.
And, I know you said your fundraising person and your outreach person was not there. And could you explain, you mentioned doing a Culver fundraiser, because you said you lost fundraising this year because of the situation going on. How did you develop that Culver fundraiser and promote that?
Well, we went on a Zoom meeting and just made a list of all the places in town. Culver's happened to be the first one that would accept our offer. We called multiple places, such as Pizza Hut and Planet Stuff beforehand, but Culver's was our big one that kind of was the step in the door for all of the other fundraisers that we did.
And what are the, go ahead.
When you're standing at Culver's and someone comes up to you and says, "Why should I give you $20?" What do you tell them? When you're trying to do some fundraising.
Well, the fundraiser at Culver's was more of a, if you bring in a flyer, then you get the percentage of the money you pay to Culver's goes towards the team, and not a, can you give us money type thing.
So it was strictly a fundraising, not a sponsorship based or an outreach event combined? Your outreach this year, what did that look like? If you were able to do anything?
For this year, we didn't quite have the opportunity to do what we did most years before, because and last year we tried to do something with Girl Scouts, but that didn't work out. But we just couldn't quite figure out what we could do for outreach this year.
I noticed in your portfolio you wrote about annoying paperwork. I will tell you that that's the life of an engineer or any professional, really. So get used to it.
Thank you guys so much. What's your favorite part of your robot before we leave?
We like the launcher. It's just kind of fun just to kind of full power just launch rings across the classroom.
I think it's,
What's your record?
Oh.
How far will it shoot?
we hit the ceiling once.
Yeah, we hit the ceiling once. That was fun.
I enjoy
That's a
how
little more
aggressive
than you
the arm is whenever it slams up and down.
Yeah.
The wobble bowl.
Wheel of Death. What about the Wheel of Death or whatever you talked about?
Yeah, the spinning wheel of death. It's the wheel that we use to launch the rings. So that
Oh, I
guy,
see.
yeah, gets going pretty quick.
I like the wobble bowl reference, because the wobble bowl doesn't, like, it gets kind of pushed to the side, but I like a good wobble bowl arm too, so.
Thanks.
Okay,
You-
oh, go ahead, Gene.
Can
Yeah.
I look at the intake? It looks like it pivots down.
Yeah, sure.
Could you explain a little bit about how it works and why you chose that design?
Yeah, so the way this one works is once we get to the driver control period, we'll just drive it aggressively forward and backward, and typically it'll fall down. And that's kind of how we were able to get this to work in the time that we had. So like it would have been nice to like kind of motorize it, but we didn't quite have the time to figure out how that might work.
And also we didn't quite have the time to make it small enough so we could do it that way with motor. without having it stick out too far.
Thank you.
Thank you, guys.
Thank
Have
you.
a good rest of the day.
Thank you.
Thank you guys also.
Okay, so I guess we're done.
Wow, good job, guys. Woo! That was awesome.
Let's just stay in there.